All right, so 9.4 or 10.4, we are talking about inscribed angles inside, and polygons inside. Inscribed means inside circles, or it means inside something. So in this case, we're talking about inside a circle. So 10.7 is saying measure of an inscribed angle theorem. So the measure of an inscribed angle, so here's my inscribed angle, it's the angle inside the circle, is half the measure of the intercepted arc. So it makes this arc right here. So let's say that this arc is, I don't know, 120 degrees. That means that that angle inside the inscribed angle would be 60 degrees. It's half of it. Okay? So if two inscribed angles of a circle intersect at the same arc, then the angles are congruent. So if you notice, we have this angle that makes this arc, right? But then we also have this angle that also makes this arc. So those arcs are the same size because it's the same arc. So if those arcs are the same size, that means that this angle C and this angle D would be congruent to one another. And they would be half of whatever the outside arc is. So if the outside arc was 60, that means angle D, which is congruent to angle C, would equal 30 degrees. So it would equal half of that. If a right triangle is inscribed in a circle, so what I have here is I have a right triangle inside this circle. Okay, if it's a right triangle, that's where my 90-degree angle is. Then the hypotenuse has to be the diameter of the circle. So this hypotenuse turns out to be the diameter of the circle. Conversely, if one side of an inscribed angle is the diameter of the circle, then the triangle is a right triangle, and the angle opposite the diameter is a right angle. So always that angle. So this is its definition, and then its converse. Its hypothesis and its converse. Theorem 10.10 says a quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. So this angle has to equal, or this angle plus this angle, they don't have to be equal. But angle E plus angle G would have to equal 180. And angle F plus angle D would also have to equal 180 degrees. Okay, so the opposite angles have to be supplementary. And supplementary means equal to 180 degrees. Okay, so find the indicated measure. Go ahead and try 1 through 6 on your own. So pause me, unpause me when you're done to see if you're correct or to answer hopefully any questions that you have. So to find angle A in here, it's just half of that. So I'm going to take 158 and divide by 2. And I get angle A equals 79 degrees. B to C, so if I'm going that way, I'm going to multiply by 2. So that would be 80 degrees. Angle B, so remember this is the diameter. We have a triangle inscribed, so that triangle has to be a right triangle. So that means that angle B is the right angle, and that would be 90 degrees. And I know that it's the right angle because it's across from the hypotenuse. B to C, so that is showing me that's 90 degrees, so I'm going to double it to come out here, so that's 180 degrees. That would also make this, if there was a line connecting it, it would make that the diameter, because half of a circle is 180 degrees. Angle C, again, we have, this is the diameter, that means that this is 90. So in a triangle, there's 180 degrees. So I'm going to take 180 minus this 90 to leave me with 90. And then 90 minus this 50 to give me angle C up here is equal to 40 degrees. One more, same thing, right triangle. So there's that. They want to know arc BC. Well, in order to get arc BC, I can get this angle measure first and then double it to get that arc. So this, again, triangle 180 degrees. So I'm going to take 180 minus the 90 degrees from the right angle right there, minus the 64 degrees right here, and I get 26. The arc is not 26 because I'd have to do 26 times 2, double that arc, or double the angle measure to get the arc. So the arc is 52 degrees. All right. Next page. Go ahead and try 7 through 9 on your own. So pause me, unpause me when you're done. Okay, so this is a diameter because it goes through the center. That means all the way around to from S to U would be 180. I can get T to U because I double 61 to get 122. So now I'm going to take 180 minus 122, and I get that S to T is 58 degrees. A to C, so this is 48, so double that. So I'm going to do 48 times 2 to get 96. And then we learned in last section that this is equal to this, which makes this arc equal to this arc. So I'm going to take the 360 all the way around. I'm going to subtract off that 96 that we already know about, and I get 264. And if those two are equal, I'm just going to divide this by 2 just to get one of those, and I get 132 degrees. Next one. So this is 94, which would make this. That's a central angle. Remember, central angles meet at the center, and they are equal to the arc angles. So that is 94. I can then find B to C, because B to C to D is a semicircle, so that's 180. So I'm going to do 180 minus 94. That leaves me with 86 here. Now, the reason I did that is because if you can see, this inscribed angle here makes that arc that is 86 degrees. So to go backwards to find the angle, I divide by 2, so it would be 43 degrees. All right. Next, find the indicated measure in circle M. So this is a diameter, which would make that 90, and make that 90. So to find this angle in here, this is the arc that it makes right here, so 68, so I divide that by 2 to find 34. So right now what I'm doing is I'm actually just going through and finding different angle measures that I know right away. Q to P and P to N make this arc of 118, so I'm going to divide it to find Q, to find P, sorry. So 118 divided by 2, so this angle is 59. Then I can also find this angle up here because this plus this plus this will equal 180 because that's a right triangle. So I'm going to do 180 minus 90 minus 59. And I get this angle up here is 31 degrees. Same idea over here. I'm going to do 180 for that triangle minus the 90 degrees minus the 34 up here. 180 minus 90 minus 34. And I get 56 degrees down here. So hopefully that'll answer most of them. So P to N to O. P to N to O would be that 34 degree angle right in there. P to Q. Oh, P to Q is right here. It would be double this angle that makes it. So double of 31 would be 62. Q, so I'm going to label that as we go. Q to N to P, so that angle right in there, which is 31. Q to O, so here to here would be 62 plus 68, so that's 130. P to O to N, that's a 90 degree angle. And then N to O to P. So go around in the circle the way that it tells you. That goes diameter in to N, so that's 180 degrees. All right, a couple more, guys. So this goes off of Theorem. Let's look on the front real quick. Theorem 1010, where we have a quadrilateral inscribed in the circle, so the opposite angles are supplementary. So knowing that, go ahead and pause me and try 16 through 19 to see if you can figure those out. Unpause me when you're done so we can go over it. Okay, so these two have to add to 180. So I'm going to do 180 minus 68. And I get angle angle X is equal to 112 degrees. And then I'm going to do 180 minus 104 to get Y, and I get Y equals 76 degrees. On this one, it is saying that these two angles right here, X, or angle D and angle F, are equal to each other. Well, they have to add to 180. So if they're equal to each other, we just take 180 divided by 2, and that gives me that X is 90 degrees. And then here, those two are add to 180. So if I do 180 minus 98, I get 82 degrees. All right, so down here, to find X, well, X opens up to K to L to M. So I'm going to add those arc measures, so 52 plus 80. Then I'm going to divide that by 2 to get the inscribed angle. We divide it in half, so X equals 66 degrees. And then these two have to add to 180, so I'm going to do 180 minus that 114. And then Y is also 66 degrees, and that is okay for those to be equal. Next, Y is made from adding e to h to g, so the 108 plus 104, but then dividing that by 2 to go backwards to the angle, and I get y equals 106. Then x, same idea, we're going to add 108 and 75 because it opens up, that inscribed angle opens up to that arc. So 108 plus 75, but then I'm going to divide that by 2, and I get 91.5, and those are all degrees. Okay, find angle A and angle C. So this one, angle A, opens up to this arc right here, right? Well, doesn't this angle also open up to that arc, which would make these two angles congruent to one another? So angle A equals 40 degrees. Angle C, so now angle C opens up this way to this arc. Angle D opens up to this arc also, so those angles will be equal, so that is 32 degrees. On this one, angle A, is equal to this arc, but angle B is also equal to that arc, so they're going to be equal measurements, so that's 45 degrees. Then angle C opens up to this arc, and angle D opens up to that same arc, so those two are going to be equal. So I'm going to do 2x plus 8 equals 3x minus 24. I'm going to add 24 to this side, so I get 32. Subtract 2x from this side, and I get x equals 32. But they don't want that, even though I put that in a box. They actually want us to find angle C, so I'm going to plug in 32. So I'm going to do 2 times 32, which is 64. 64 plus 8 is 72. So angle C equals 72 degrees. All right. So after this section, there is a 9.4 homework assignment that you need to complete, and then you need to prepare, study, and take the quiz. All right. Thanks, guys.